Our topic today is ions. If an atom is electrically neutral, its number of protons are equal to its number of electrons. And that means that the number of electrical charges are balanced. So for instance, let's look at an electrically neutral boron. Boron is atomic number 5. So in a boron, an electrically neutral boron atom, it has got, with atomic number 5, that means it's got 5 protons, and all the protons are positively charged. So 1, 2, 3, 4, 5. Okay, this is boron. So it's got 5 positively charged protons, and it's got 1, 2, 3, 4, 5 negatively charged electrons. So for every negative charge, there's a positive charge that neutralizes it. And so overall, we say that the boron atom is electrically neutral. The number of protons is equal to the number of electrons. Atoms can, and they often do, lose or gain electrons. In very simplistic terms, this happens because the atom is seeking stability. And for an atom, 8 is the stable number, meaning 8 electrons in the valence or outermost electron shell. Very simplistic. We will talk a lot more in depth about this later in the year. But for now, what we need to keep in mind is that atoms lose or gain electrons. And they do this in a very predictable way. This happens in simplistic terms because the atom is seeking stability. Okay, I use the word seeking. It's not looking out for it, but this is where it is, well, I don't want to anthropomorphize. And 8 electrons in the valence shell is stable for an atom. Do atoms gain or lose protons? Absolutely not, unless we're talking about a nuclear reaction. Nothing changes to the number of protons in an atom, unless we're talking about a nuclear reaction. So the way ions form is losing or gaining electrons only, and those being the valence electrons, the outermost electrons. Those are the only ones that can be gained or lost. Okay, very predictable. And in January, you'll understand why metals tend to lose their valence shell electrons, and nonmetals tend to gain valence shell electrons to get to that magic number of 8. When atoms lose or gain electrons, they become electrically unbalanced. Their number of protons are no longer equal to the number of electrons. And this will end up giving them an overall charge. And we call these charged atoms ions. Okay, so what does this look like? Let's do a quick little diagram again. So for instance, let's go with oxygen first. Oxygen is atomic number 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a neutral, oxygen. When oxygen becomes an ion, it always becomes an ion with a -2 charge, meaning that it gains 2 electrons from another atom. Who's willing to give theirs up? Okay, so if we see this, and we're not talking right now about why it is that it gains 2. It gains 2 so that it will have a full valence shell of 8 electrons. But it's got 2 extra electrons here. So these all balance, right? Neutralize one another, but we've got these 2 extra electrons, so that gives an oxygen ion a -2 charge. And oxygen will always have a -2 charge. There's one exception, but we're not going to talk about it right now. Okay, let's go to sodium. Sodium is a metal. Metals tend to lose electrons. We don't know why yet, but we will one day. I mean, we do, but you guys don't. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the neutral sodium has got 11 electrons. But when sodium becomes an ion, it loses one of its electrons. It loses its only valence shell electron to become an sodium +1 ion, a sodium ion. Sodium has always got a +1 charge when it's an ion. Has it gained a proton? No. They never lose or gain protons, people. All they do is gain or lose electrons, and in this case, sodium has lost 1 electron, so now it's got a positively charged proton that is not being neutralized by an associated electron, and so now it's got an overall +1 charge. Neutralize, 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 neutral, 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 leaving us with a +1 charge. Neutral, neutral, neutral. Leaving us with an overall -2 charge. They've got special names. Atoms with more protons than electrons. Okay, so these are atoms that have lost electrons. They've given them up to another atom. These are known as cations. Not cations, cations. Okay, so again, why do they have more protons than electrons? Because they've given up some valence shell electrons to another atom. They've lost electrons, given them up to another atom. So overall now they've got more protons than they have electrons, and that's going to give them an overall positive charge, and we call them cations. Atoms with less protons than electrons have a negative charge. Okay, so they've picked up electrons from another atom that's willing to give theirs up to achieve stability. So they've gained electrons, they've got more electrons than they have protons, they have now an overall negative charge, and we call them anions. So cations are ions with a positive charge, and they've gotten that positive charge because they've given up their electrons, their valence shell electrons, to another atom. And anions are ions that have gained electrons. So they have an overall negative charge. They have taken valence electrons from another atom that's willing to give theirs up for stability. So now everything's got 8 electrons in its valence shell. What's the important thing to know? Cations are ions that have a positive charge. They've gotten that way because they've given up valence electrons. They've lost valence electrons. Anions are ions that have a negative charge, and they have gotten that negative charge because they have picked up, they have gained extra electrons, valence shell electrons, from another atom. And finally, we have these things called polyatomic ions. And polyatomic ions are groups of atoms that behave as a single atom. You have flashcards representing some polyatomic ions. Ammonium, NH4+, nitrate, NO3-, nitrite, NO2-, acetate, C2H3O2 with an overall -1 charge. Okay, these are known as polyatomic ions, and we think of them really as acting as a single unit, a single entity. They act like an atom. They always travel in bunches, for as much as we need to know right now anyway. Okay, that's an ion. It's a charged atom.